Then you gotta tell me how many pennies you have on how many cents you have in your bag right now. You know, my money's in the corner. Oh, how much money in your bag?
Everyone, I think we're going to go ahead and get started. It is the top of the hour. I want to be respectful of everybody's time. I'd like to welcome you all to our webinar today. So this is Advanced Decarbonized Manufacturing on Tribal Lands, presented by Dr. Ramon Sanchez. Dr. Sanchez is indigenous to the Mayo and Yaqui people of coastal regions of Sonora and Sinaloa. Dr. Sanchez provides strategic leadership planning for his organization, Alliance for Tribal Clean Energy, and the tribes it serves, supporting integral sustainable development, innovation, and field knowledge management alongside initiatives for organizational continuous development. He fosters community development, community partnership development, driving change through innovation, education, and workforce training using the best available technology and didactic tools. Welcome, Dr. Sanchez. Thank you for coming today and doing this presentation. And we'd also like to thank NSF for the funding to be able to do this work or webinar today.
Thank you so much. And I really appreciate the invitation. And I'm going to start sharing my screen so we can actually go into today's materials. But I want to share that, as Elena mentioned, I'm a Yaqui Indian, Yaqui and Mayo, and I have been working in decarbonizing different activities since well 1996. Okay, so it has been a long time for me, almost 30 years. And when I started in this, I did it because of manufacturing operations, for cost reductions in manufacturing operations. But I want to share my experience with you. And let's see, right now I'm Chief Knowledge and Innovation Officer at the Alliance for Tribal Clean Energy. And before, I used to be, first, I was an automotive engineer, a mechanical engineer. Then I got a master's in manufacturing systems, and I was running manufacturing operations in different parts of the world. And so I'm going to start talking about my experience, so you have an idea about what what and how this relates to you, all of you. So I started in 2004, and the reason was the local government in California was offering fiscal incentives to go sustainable, to go green. The only reason why they were doing that is because we were having an energy crisis at the time. There wasn't enough energy, and commodities were really, really expensive, meaning all of the metals, all of the cement, all of the everything was really, really expensive. And that's why they issued that request to go green, to try to save energy and resources. And so at the time, I was managing a manufacturing company that was producing consumer electronics and furniture. And my goal was to save $2.6 million that will be tax deductible with this government offer. And let me tell you what the results were at the end. We ended up saving 40% of our operating cost. That's $68 million. And we reduced our greenhouse gas emissions by 32%. We reduced our energy use by 23% and our overall environmental footprint by 35%. And we did it in 14 months. And you may be wondering how did that happen, you know? Well, part of it was training people to participate in the program. We will give them an incentive, like 10% of anything that we were saving, we will go to them, to the people that proposed an idea that will save money or will make things more sustainable. And essentially, that's how we did it. At the end, we got wonderful results. We were able to manufacture faster. We reduced personnel rotation, increased productivity, and by training 1,200 workers, we actually ended up having a benefit cost ratio, meaning for every dollar that we spent into this project, we got $11.3 back, you know, in savings. And as mentioned before, we reduced our environmental footprint by 32%. No, our greenhouse gas emissions by 32% and our environmental footprint by 35% on everything that we were manufacturing. When people monetize the environmental and health benefits as well, it was more than $25 per dollar spent. So I came into sustainability because of the money. And I decided to go back to graduate school. So I applied to go to Harvard University for a mid-career master's just to learn how to estimate the environmental footprint. And to my surprise, I got accepted. And there were no professional development programs that will teach you how to do that anywhere at the time. So I was really happy because it will be 9 months from September to May just to learn, to get a master, to learn how to estimate health and environmental impacts. But somehow the people in the university believed that it was valuable to have someone like me there, and they asked me, "Would you like to apply for the doctoral program?" And I did, and to my surprise, I got accepted as well in the doctoral program, and that completely changed my life. I wasn't in manufacturing anymore, but I was helping people in manufacturing. And let me elaborate on that. Well, after I graduated, I got a job as one of the directors of the sustainability program, and I was also principal investigator, and I became director of the Sustainable Technologies in Health program, which were the commandos for sustainability. All of the technologies to reduce our environmental footprint and our greenhouse gas emissions will be in one particular place. And we would try to reduce or find ways on how to implement these technologies in real life. And right here, I have the diagram of the overall greenhouse gas emissions. As you can see, energy represents 73% of that. And it could be energy in the form of electricity or liquid fuels for transportation or anything for heat or petrochemical activities, etc. And so I started to teach a course, well, two courses at Harvard at the time. One of them was sustainable product design, and the other one was sustainable manufacturing. And so you through the years, probably I have trained probably 4,000 people and at a graduate level on both things, sustainable product design and sustainable manufacturing. But usually most of my students took both courses because they wanted to specialize on sustainable industry, period. And that's essentially something that we will check. Now let's go to a little bit of background. How did we get here and how did we get an opportunity for tribal communities? Well, you may know about the northern and midwestern regions that got deindustrialized starting in the 1980s. And people lost their jobs because corporations were leaving and going somewhere else due to globalization. And but it wasn't only globalization; it was also automation, and it was a big deal. So we are still facing the adverse effects of that. But you have to know that everything started there for manufacturing. So jobs went overseas, and we have like the expansion of globalization in the 1990s and early 2000s. A lot of jobs went somewhere else. We could discuss how that happened, but that is not the nature of this presentation. So whenever you want to invite me back to see how that happened and why it happened, that's great, but not right now. So something fundamental changed in the early 2000s. China was admitted into the World Trade Organization, meaning that they had the same rules as everyone else on um, manufacturing things, and that will open markets for for Chinese products going anywhere. And you have seen how China became one of the prevalent manufacturing centers of the world. Okay, but some people call China the world's factory, and so that's something that just happened. Well, recently it was 25 years ago, so it's recent. So in the 2010s, we have the maturity of globalization. Um, we started to have factories somewhere else, particularly in Southeast Asian countries, and people started to outsource a lot of things. And that's why we started to lose a lot of manufacturing jobs in the United States. You can see this graph right here. The peak for manufacturing jobs was in 1989. It was around 21 million jobs, close to that. And this is where we are right now at close to 14. Right now it's 14.5 million, the last time that I checked. So we lost a lot of manufacturing jobs, close to at least 6 million manufacturing jobs in the United States. Okay. However, recent geopolitical risks um, really are making China not that favorable as a place to manufacture. And that's why um, that's well, because of that and the pressures to actually reduce greenhouse gas emissions worldwide for corporations, particularly Europe. They have an environmental law. Well, yeah, the environmental, no, the climate law of Europe states that corporations or anyone really in Europe needs to decarbonize by the year 2050, but they have a midpoint goal of decarbonizing by 55% by 2030. That's 5 years from now. That's why any corporation that is selling anything in Europe needs to decarbonize at least by 55% in 5 years. And that is the main pressure of why they decided to leave China in a sense, but also the geopolitical risk. And for the United States, it was also about intellectual property infringements. Like, I don't like to use the word theft, but technically, um, some some actors in China, they were mishandling intellectual property, and you can see the breakdown right here. And people didn't like that. So, 25 years ago, I was managing three manufacturing plants. No, 24 years ago, I was managing the three manufacturing plants in China. Two in north of Shenzhen, which is in the southern part of China, and one in Suzhou, which is west of Shanghai. And the situation wasn't that bad at the time, but I remember how I started to see some of our suppliers actually double manufacturing what they were selling to us, and then they will sell that in the I don't dare to say black markets because it was the regular market, but they were double dealing, let's say it that way. And we started to find out that they were doing those things. And when we caught them, they will stop, but they will continue doing that. So fast forward 20 something years, and probably that's that kept going, and probably with the government. And you can see some examples right here of mishandling intellectual property. Yeah, this is called Obama Fried Chicken, by the way. It's real. And it was a chain in China for fried chicken. Mikey instead of Nike, sneakers, or Olebs instead of Rolex. Still, they were mishandling those things. But the problem wasn't that. If it was just trinkets or things like that, it was a theft, but it wasn't really damaging. The problem was when they started to mess with anything that was going to manufacture goods that were related to national security in the United States. That was the real problem. And that's why they decided to onshore high-tech products and chips and so on, because they saw that risk. And this is where we are right now with the trade wars. I don't have to tell you about what's going on. You have seen the news, but we are right there at that point where probably most products in the United States are coming back home to be manufactured locally. And how is that related to tribal communities? Well, there is something special about manufacturing in the past 30 years. Um, we have something that manufacturers were using that were called the special economic zones. So in this map of China, you can see some of the special economic regions. Like in these places, you will have a special tax breaks or expedited processes to facilitate manufacturing, or there will be government-sponsored workforce development programs so we could have workers, etc. So that's special economic zones, and manufacturers got used to that. In the U.S.-Mexico border, there is one that goes down 12.5 miles south of the border. This is a special economic zone for Mexico, between Mexico and the United States. And that one, you can actually import any materials or supplies into this special economic zone in the border between Mexico and the United States. You could import materials, process them, and then send them back to the United States without any taxes. And this started in the 1990s, okay? Well, late 1980s or very early 1990s. So as you can see, manufacturers got used to special economic zones. And well, this is essentially what the special economic zones do. They provide tax incentives. So, for example, instead of paying, let's say, the 21% in corporate taxes for manufacturing something in the United States, um, in China, you will pay nothing, or you will pay like 10% or something. In Mexico, you will pay nothing. What about, well, I don't want to get ahead of myself, but you get the idea. Then you have a streamlined regulations. Like, for example, instead of having very bureaucratic processes to import things and to export things, or any special things that the national governments will impose on those special economic zones, you will have streamlined processes. So the infrastructure will be also geared into supporting manufacturing operations, like roads, for example, um, renewable energy facilities, energy generation facilities, communication networks, etc. And as mentioned before, they will have special programs for workforce development to have, so manufacturers will have access to skilled labor. I remember that in the early 21st century, I was teaching a class on lean manufacturing in China. Okay. And I was like, I'm not a teacher. How come I'm teaching? Well, it happened to be that they didn't have a lot of people that knew about that. And so, um, because of the agreement between my company and the Chinese government, they had me teaching lean manufacturing in China. And it was like in my spare time and the whole thing, but it was also helping my company because then I will get skilled labor. And the other thing is that they provide fiscal incentives for design centers. So you can do research and development there at a lower cost, and that will improve your products and your manufacturing processes. So those are the special economic zones. And here it comes, and how that relates to tribal communities. There are special economic zones within the United States. They are the tribal reservations. So because of tribal sovereignty, tribes can create their own laws, govern themselves. They can create special economic activities. That's why you have a lot of gaming activities in many tribal communities, or you may have partnerships or co-ops and so on. But that's something that can only happen at tribal governments or reservations. Okay, why? Um, in any corporation working in the United States will have to pay like state taxes, federal taxes, many other things, and so on. And that applies everywhere except tribal communities. Okay. So you may still need to pay something, but in reality, the tribes will determine some of the fiscal um, incentives that could happen there. Like, for example, instead of paying 21% corporate tax, a corporation may pay only 10% corporate tax, but to the tribe, not to other entities. And so, how can we benefit from this? Well, let's go into that. We have three things. One of them is requiring substantial equity on any new corporation, manufacturing corporation on tribal lands, and to do tribal workforce development to create jobs. Then selecting the right level of automation for the factories. That may seem kind of weird, but you will see why in a few minutes. And then decarbonizing manufacturing and logistics, because that's what the global economy wants, regardless of what the situation is in the United States. So let's go into the first one. How do you say requiring substantial equity? That means that the local government is co-owner of any new manufacturing facility. They could be minority shareholders, but minority shareholders means that they will have from 1% all the way to 49% of the new factory. And that is stipulated in the contract that any manufacturing corporation creates with the local government in a special economic zone. So let's say that the tribe was the owner of 25% of the new manufacturing corporation, meaning that 25% of the profits will go directly to the tribe. It's and then the capital will come from the manufacturing companies. One of the appealing things about tribal communities is that you have no hard borders. So technically, you could operate in some factories, and I don't mean the factories that pollute. I mean assembly factories for consumer electronics or for certain consumer goods or something that are very simple. You could operate them on tribal communities and just send them to the rest of the country without any taxes, without any problems, well, any tariffs in this case, because you are operating within the United States. So the tribe owns part of the corporation, the manufacturing corporation, but also mandates tribal workforce development, meaning that in order to have the workforce for these factories, the companies will partner with different organizations to train people so they can work in these factories. And in this case, it's a win-win in the sense that not only you are bringing economic development through manufacturing, but also you are creating jobs. And in some tribal communities, on some reservations, unemployment may be as high as 75%. So this may be a really good opportunity for that. The level of automation is something that is kind of weird, but let me try to describe it a little bit. The level of automation means that instead of buying the biggest, most automated machine available for your factory, you can consider, well, what will be your production volume and try to go to agile manufacturing, which is the Toyota production system. But why is that good? Because if you buy the biggest machine, the most automated machine, then you can produce anything else on that space, on that manufacturing facility. And not only that, you will consume the highest amount of energy possible. Okay, that's the problem with that. So instead of that, you train people about the different techniques or different types of production systems. And then in this case, the tribal community and the manufacturing corporation will define the manufacturing process to try to minimize this energy consumption since the beginning. And I have one example. The Toyota production system is something that produces, let's say, hundreds of thousands of items per year on a factory, but you have product um, diversification, meaning that you have different types of products that could be produced on the same manufacturing floor. And this is how you produce cars with different colors, different models, different things in the same manufacturing facility. That is the Toyota production system. Okay. That enables you to change or to switch your equipment and to consume the least amount of energy possible. Okay. But you also have the mass production system. In this case, you have standardized all of the product features and you decrease product variation. And the problem with that is that you will have to purchase the biggest equipment available, something that you cannot move, something that uses the highest amount of energy. And that's something that we don't want. The problem was in the early 20th century, this was favored. The mass production system was the one used by Henry Ford to produce the Model T. And that was the problem. And so most of the manufacturing corporations were using the mass production product in the first half of the 20th century. And so the whole thing is precisely trying to reduce the amount of energy that you will consume from the beginning. But that is almost like a theory. Probably we will require another seminar just to talk about that. But the level of automation is not insignificant. And also, the level of automation, if you have a high level of automation, you have less workers and therefore less benefits for tribal communities. That's why we need to be really careful about the level of automation that we would like to have on any operation on tribal lands. But then we go to the most important thing, decarbonizing manufacturing and logistics. And this is why I think I was invited to this seminar. And the first thing that we try to do is to reduce waste and improve production yields. What do we mean by that? Well, any opportunities to improve production yields, we have to take them and to reduce waste. I have one example, maybe it's not like the greatest one, but it's something that I can explain in just a few minutes. We were having a big problem when I was manufacturing leather upholstery products. So the problem was that you will have something like the cowhide. You can see the layout here is the red line right here. And you had imperfections. And in the early 21st century, we will have a computer determining how to cut the leather so we could have the seats and the backs and the arms and so on for upholstered products. But the bigger the size of each one of these parts, the lower the production yield. And because of that, we will only use 50% of the leather, meaning that we will be wasting 50% of it. And leather is one of those products that is very carbon intensive. Maybe is not producing greenhouse gas emissions in my factory, but is producing greenhouse gas emissions for my supplier. And the goal is to reduce overall greenhouse gas emissions. So what did we do? We started to create themes to actually reduce the size of some of these big pieces, that we would have for later. And we did it in places where the people didn't notice, or didn't know it was below the eyesight of the people and so on. But by doing this, we went from using only 50% of the leather to using 92% of the leather. So our production yields went up because of this. And that's really important. Okay, so first one, to reduce waste. I could have had several examples, but I know that you want the other technologies a little bit. So let's go to the other ones. Then um, improving energy efficiency. And in that case, for example, what we started to do were like energy audits in our buildings, doing thermal scanning just to find out where we were losing energy. Um, and based on that, we will actually reinforce the insulation there, or we will have like double pane glass windows or triple pane glass windows or something else, or we will reuse heat in other operations just by doing something like this. I have a good example of something that we were using. This material is called aerogel, and it was developed for airspace applications. But it's a really good insulator, and you can apply it as foam or as a paint coat. So we decided to actually paint or repaint our whole manufacturing facility where we were. And to give you an idea of the size of my factory, it was 500,000 square feet. So it wasn't a small one. And we decided to give it paint coat with aerogel. However, that reduced our overall electricity consumption by close to 12%. So insulation matters, and people should be considering that. We also started to install dynamic glass windows, particularly in any places where we had like well, not only windows for offices, but also windows that we were using to introduce natural light to the operation, and we started to change them. So you call them self-tinting windows, and essentially when it's very hot outside, they will create a layer, so it will tint by itself, and because of that, it will not let you know the it will not let the sunlight in. But whenever we had some well in this case um, mm, well not enough solar irradiation, then they will be completely transparent and they will let light in. So that's essentially what it was. We also were experimenting with electrochromic glass at the time. Imagine, it was 20 years ago. Electrochromic glass means that when you um, apply an electric field to that particular glass, it becomes opaque like this. And we were using that to moderate the amount of light and to reduce our energy consumption inside. Um, uh, this is something new, so we didn't use it 20 years ago, but this is something that a lot of manufacturers are using as we speak. And this is managing the albedo, meaning the reflectivity of their roofs. And just by painting your roof white, for example, you may reduce your energy consumption by 3 to 4% just by painting it white. Sorry, and so what happens is that there are new paints. It's called the whitest paint, and that reflects 80 to 98% of sunlight. And in that case, you may get very significant um, savings, close to 30% instead of 3 to 4%. And you can see it on this thermal image, the whole thing. With whitest paint is actually cool to the touch, even compared to the surrounding areas. And this is the other one, which is slightly better, but not so much. It's slightly better than the surrounding areas, but not so much, not by much. We started, at the time, we were using geothermal heat pumps, meaning that you will have coils full of glycol going underground to actually transfer heat inside our planet and then get heat from inside our planet. But we don't need to do that anymore because of air source heat pump. In this case, you have a heat pump that is like a bidirectional HVAC system, and um, and you have a fluid, a cooling fluid that actually evaporates at 20 degrees Fahrenheit, so at very low temperatures, really. And so, anytime that you evaporate the fluid inside in one of the coils, it will attract heat. Okay, it will trap heat. It will draw heat. So, in the summer, you evaporate it inside the building to cool the building, and in the winter, you actually switch the whole process. And what you do is that as long as the air temperature is higher than 20 degrees Fahrenheit, you can evaporate the fluid here outside, which will trap heat. And then you go and dump the heat inside the building. That is an air source heat pump. And this is a recent development because I have only seen them in the past 10 years. And this may save between 50 and 67% of electricity consumption related to HVAC systems. And that's in the factory. Another one, and this was one of my favorites 20 something years ago, were solar thermal heaters. Solar thermal heaters were really good because they were super cheap. They will essentially create like mini greenhouse effects here to heat water, and um, and then they will pay by themselves in 1 year, and then you will have 29 years of hot water, meaning that the ones that I installed in 2004, sorry, 2004, are still working and are still providing savings, even though they were installed 20 years ago. So they are really good, but also generating energy on site when possible. This is a picture that comes from a factory, and it's something recent. And essentially, you can transform or self-generate electricity at the site of consumption. And that reduces greenhouse gas emissions by more than 90% by doing something like that compared to fossil fuels. And an opportunity in tribal communities, you may also have like solar farms or wind farms nearby. Whatever, you don't have any sacred land, whatever, you can use the land, whatever is feasible, you can have that energy and then provide it to the factory. And that way you decarbonize any energy consumption inside the factory. This is one of the biggest things for anything that is only using electricity. Like, for example, when you are assembling consumer electronics, that will reduce the carbon emissions for the factory by more than 90%. So this is why it's so important to go green into some of these factories, and you save money. In one of the factories where they were paying close to 15 cents per kilowatt hour, because that was the industrial rate, and the reason why they were charged so much in that community was because they were using so much energy that they needed a bigger power plant for the grid to service the factory. So they were being charged between 15 cents per kilowatt hour and 25 cents per kilowatt hour, depending on the demand, that the local demand for electricity. So when they switched to renewables, they found out that they could generate at 7 cents per kilowatt hour using solar, and they could, with battery backup systems, just a little bit of additional cost just for certain operations, it will go to 9 to 10 cents per kilowatt hour. Still, it was better than 15 cents per kilowatt hour. So they were saving at least 30% on energy costs. This is an advantage that tribal communities have that no other community has. So in this case, um, the tribal community could actually provide the electricity for the factory and charge the factory, whatever the situation is, or partner with them. And this will be a joint facility for the operation. But it can only be done on tribal lands right now. That's the whole thing. And when you start checking what is like the price for electricity for different things, by the way, this is rooftop photovoltaic. So I apologize for this because the real number for this will be about 6.5 cents per kilowatt hour for the large scale utility scale solar. But you can see that we are getting there. So the production cost for the electricity for renewables is lower right now than the local grid for many of these things. And these are the greenhouse gas emissions that you will achieve with different technologies. So the only difference between a rooftop system and a utility scale system is the cost. The more you buy, the lower the cost per megawatt install or per kilowatt install. And that's why I have to apologize on this graph because I should have placed 6.5 cents, which is the real cost of photovoltaic, but at a utility scale. But greenhouse gas emissions are the same, you know. I mean, for every technology compared to the US grid, and with photovoltaic, you will reduce carbon emissions by 92%, with onshore wind by 98%. So wind and solar may be one of the best bets for decarbonizing manufacturing operations. But something real important is the local jobs that are created for renewable energy projects. So for wind, you create at least 10 jobs per megawatt install. So if you have a 50 megawatt solar farm, you will create 500 jobs for 1 year. Those are temporary jobs, I agree, but they are jobs still in the community. And that's why you will need to do workforce development, not only for the manufacturing operations, but for people that may want to install these things, or even the double whammy, which is the best one. You train people to install solar or any of the energy systems, and then you retrain them for manufacturing operations. So they work in the construction of the renewable energy facilities, but also they work in the manufacturing facility later on. That could be for wind. For many people, solar is the way to go because it's easier to and less demanding for many communities. You generate 4 to 5 jobs per megawatt, but then you generate at least one permanent job per megawatt for each one of the facilities. And this is to maintain the renewable energy the facilities. So you generate a lot of jobs with this. And people were asking me in tribal communities, what about sandstorms? What about hailstorms? What about those things with solar? And that's why I want to show you intermetallic solar panels. Essentially, they put some intermetallic compounds and then they cover them in semiconductors and they generate solar energy. You could have a hard substrate, like in this case, this is hard rubber, and then they put the thin film semiconductors, or it could be rubber like this. So it could be like in a roll. But the most important thing is you can drill them, hammer them, bend them, etc., and they will still work. So you can see this guy has stepped all over these solar panels, and well, these are not regular solar panels. They are intermetallic solar panels, so they can take the weight of this and still work. And the other thing is that they weigh about 90% less than regular solar panels. So you can install them on the top of metal roofs, or any industrial roofs or anything, or even manufactured homes. So that's what is good about them. You can also, if people are concerned about huge wind power systems, I want to show you that there are ways to generate locally using bladeless systems. These ones, they move and they generate electricity. They are not, they don't have any blades. And they are about 40% cheaper than regular wind systems. And this one that is right here on this picture is a 2 kilowatt system, and it works at very low wind speeds, and it can go all the way to 200 kilometers an hour. I have no idea how much is that in miles, but it's very likely to be like 140 miles an hour winds, and it will work. So, and you could place them next to each other, and generate a lot of electricity for small manufacturing facilities. And this is a diagram inside, so you can see that it has a permanent magnet and something, and every time that there is wind, it goes back and forth and produces electricity because the magnetic field here is altered, and this element inside is actually a generator, and that's how you generate electricity, and then you send it somewhere else. But I think that the most important opportunity that we may have in tribal communities will be by coupling um, renewable energy facilities with green hydrogen. Green hydrogen means that anytime that you have surplus electricity, by any chance, you produce hydrogen, and that hydrogen could be used for different things. You can even store it for months. So you can produce it during the summer, let's say it, and then you can store it in salt caverns for months, and then take it out and use a modified combined cycle natural gas power plant and recover the energy. So you can do that. And that works not only for energy, but also for transportation, because you could have plug-in hybrid hydrogen vehicles. And that's precisely what they are trying to do. I'm going to go ahead a little bit. This is the future of long-haul transportation. They want to use um, plug-in hybrid hydrogen vehicles, because that way you can plug them in, and for the first 100 miles, they will be fully electric. And then after that, they will burn hydrogen. And this is what I want you to see. They will burn hydrogen on a small power unit working at one speed, at the top efficiency speed for that generator. So it's just a generator, not like a regular internal combustion engine that needs to operate at any speed. This one will operate at one speed just to generate. And then you generate electricity, recharge the battery pack, and from there it goes to the electric powertrain, which is 70% efficient compared to 16% efficient for a gasoline engine or 21% efficient for a diesel engine. So that's why you will have the best of both worlds if you are generating hydrogen for long haul transportation, but it will be a plug-in hybrid hydrogen vehicle. And that way you can go from Boston to LA and back just by recharging hydrogen on any stations. And tribal communities could be the ones that are doing that, and particularly if they are supporting the logistics for any manufactured goods produced in tribal communities. So this is something from Europe. We are experimenting with hydrogen locomotives. Again, it's a plug-in hybrid hydrogen locomotive. And before you think like, well, this is too far off or something, right now they are using plug-in hybrid diesel locomotives. So the only thing that they are switching is the fuel, the source of fuel, but they are working on hydrogen locomotives. And that may be really good, particularly to transport raw materials and components and other things. This may be the future. And tribal communities could have the facilities for renewable energies and also to produce hydrogen. You may be concerned about water, that's another conversation, but there is a way to condense water from the atmosphere and then use it for human consumption, but also for hydrogen production, but that's something else. Hydrogen or ammonia produced from hydrogen could be used to power boats, and that way anything that you are transporting. I know that we don't have a lot of tribal communities that have boats or well, coastlines, but still that will be something that essentially we could do. But one of the most important things, remember how I say that you could produce hydrogen in the summer, store it on salt caverns, underground salt caverns, then take it out in the winter and use it. The way to do it will be with a modified combined cycle natural gas turbine that burns hydrogen. And that way, you could recover your energy from the summer. You could use it in the winter. And I know that many communities are struggling with wastewater, but we could reprocess 98% of the water. We could recover that by extracting the nutrients and by killing the pathogens and so on, by using microalgae farming. Then one of the byproducts of microalgae farming is that you can produce biofuels. So the process is not that convoluted, but I'm going to try to explain it in a minute or less. But it's about first separating solids from liquids. Then the solids will go into a biodigester. Then the liquids, we will kill the bacteria with ozone or UV irradiation. Then we have liquid with organic carbon and nutrients. We feed it to heterotrophic microalgae. They don't do photosynthesis, they use eat nutrients. And we produce biomass, and we use that biomass to transform it into biodiesel and biojet fuel. And the rest of it will go to be biodigested to make electricity. So why is this good? Because between green hydrogen and biofuel from waste to energy processes, we can substitute, and some people are already doing that, substituting fossil fuels with hydrogen and unconventional biofuels for any industrial operations. And this is not insignificant. The uh, steel foundries and cement manufacturing accounts for 8% of overall greenhouse gas emissions worldwide. Therefore, this is not insignificant, but I want you to know that there is a solution. Green hydrogen and waste to energy biofuels could substitute any of this. Green hydrogen is cheap right now. Waste to energy biofuels are getting there. But in the next 5 years, probably we will have this transition and we are going to change fossil fuels with this in many manufacturing operations. And I'm going to stop right now to see if there are any questions, and let me know, well, if you need anything. I think that I'm going to share my information on the chat room so you can see it, but let me know if you need anything. So any questions, Elena?
Sure. I do see one question from Randy Miller. It says, how are we going to reduce the emissions by 55% when China manufactured almost all renewable energy supply chain products?
They need to reduce it, and I mean for Europeans, because either they do that or they pay a very heavy fee. Okay, so it's not that how can we reduce it? You can see that we went from just by having let me see your faces. That's important if we can. Well, I don't think so, but in this case, um, anytime that you go renewable, you reduce your carbon footprint by close to 90%. So that's part of it. Now, this is something that any company has to do. And if they are selling in Europe, either they do it or they pay a hefty fee. So that's why a lot of the corporations right now are trying to partner, doing long-term purchase power agreements to try to get um, um, these low carbon emissions or reduce their carbon emissions to try to comply with that. The problem right now is instead of helping at this moment, many people in some governments are trying to hurt this. Is they are like, let's go with oil and gas. That's what we do. But in 2030, when people need to pay these fees in Europe, that's when pain will come, and that's when people will realize that this is real. And the fees are actually not that bad in 2030. Are bad, but not that bad. In 2050, if you are not fully decarbonized by 2050 for some industries, you will not operate in Europe. You will have to abandon the European market. And that's why a lot of companies are thinking about doing this. And this is the opportunity in which they can partner with tribal communities to decarbonize their operations. And the how, you saw it, you saw the technologies, heat pumps, renewable energies, reducing any energy leaks, insulation and those things, using green hydrogen, using waste to energy biofuels, unconventional biofuels. That's how you decarbonize the whole thing. Let me see. And about China, China really they are trying really hard, but they are not going to succeed because they are still using coal. But that is not China's problem, it's the corporation's problem. Because if they don't get to that goal, they have to pay a fee. That's it. So any other questions?
Don't see any in the
Um,
Q&A, but yeah, if anyone wants to raise their hand or has any verbal questions they'd like to ask.
okay. Well, I'm going to type my email in the chat so anyone can see it. And you can contact me anytime if you have a question or you need something. Um, and I have experience in manufacturing, but also in clean energy. And the it is a great opportunity that companies are coming back to the United States, and I hope that we use it wisely. Okay.
Ramon, thank you. That was a really informative seminar, a lot of information, and we appreciate your willingness to share your expertise with us. Thank you. And thank you to the participants. Thank you,
Thank you,
guys.
Marianne.
Bye-bye.